Today we're going to look at 12.3 measures of dispersion. Okay. Let's go ahead and start by looking at the quiz scores for two students. We have student A, who had quiz scores of 3, 4, 5, 5, 6, and 7. And we have student B, who has quiz scores of 0, 3, 5, 5, 7, and 10. Now, remember that when we talk about measures of central tendency, we're talking about mean, median, mode, and range. And those are the four things we want to find for each of these students. So remember that when we find mean, we add up the numbers and we divide by the total number of data values. So for student A, I'm going to add up 3, 4, 5, 5, 6, and 7, which gives me 30. And then I need to divide that by 6 because there are 6 data values. So student A has a mean of 5. Okay. We're going to do the same thing for student B now, but we're adding up 0, 3, 5, 5, 7, and 10, which also gives us 30, and we're going to divide that by 6 because there are 6 data values, so student B also has a mean of 5. Okay. Let's check out median next. Now remember, with median, the list of data have to be ranked, so they have to be in order from least to greatest. Lucky us, they already are, so this makes my life a little bit easier. So I'm looking for the middle number for student A. So I'm going to cross off my 3 and my 7, my 4 and my 6, and I'm left with two middle numbers in this case, which are both 5. Since they're both 5, my median will be 5. Okay. Let's do the same thing for student B. I'm crossing off the 0 and the 10, the 3 and the 7, and I'm left with two middles in the number, both 5, so my median for student B is also 5. Okay. Mode is next. That's the one that occurs most often. In both student A and student B, there is a mode of 5. Okay. And now we need to talk about the mid-range. Remember, to find mid-range, I'm adding up the lowest and highest score and dividing by 2. I'm finding that average of the lowest and highest score. So for student A, that means I'm going to add up 3 plus 7, which would give me 10. I'm going to divide it by 2, and that gives me 5. For student B, I'm going to add up 0 and 10, which also gives me 10. And when I divide that by 2, I get 5. So, check this out. There are lots of 5s floating around on this screen. The mean, the median, the mode, and the mid-range all ended up being 5s for both student A and student B. But notice that the set of data we were looking at initially for student A and student B were two completely different sets of numbers. So what this leads us to is sometimes there's a need for something more than just these 4 measures of central tendency. Otherwise, we can't always tell the difference in these two sets. So in the last example, we found that those 4 measures of central tendency didn't necessarily give us a good picture of that data. Every single measure of central tendency ended up being the same. Okay? So this is where measures of dispersion come into play. Okay? Measures of dispersion measure the spread of the data items. Whoops, wrong tool. Okay. One way that we can measure dispersion is through range. Now be careful, because there's a difference between the word mid-range and range. Remember, we looked at mid-range, and that was where we added the lowest and highest data value and divided by 2. Range, however, is just the highest data value minus the lowest data value. So that's going to tell us the spread of the lowest and highest data value. Okay. So if I look back at the previous set of numbers and I want to find the range for each of those previous student scores, the highest number for student A was 7. The lowest number for student A was 3. So my range would be 7 minus 3, which equals 4. For student B, my highest number was 10. My lowest number was 0, so they have a range of 10. So we can see through this that student A had a lower range, student B had a higher range. That's telling us that the spread of data items in set A was not as great of a spread. Okay, those numbers were closer together. Student B had a much larger spread of numbers. Those ones were spread out further. Now, the range is helpful in that it compares the lowest and highest values and gives us a spread. But the disadvantage is that it only compares two values, that highest one to the lowest one. Okay? We're also going to look at something called standard deviation. And standard deviation is really nice because it uses all of the data items and it measures how each data item differs from the mean. Okay, so let's highlight that. Standard deviation measures how each data item differs from the mean. Now, I'm not going to sugarcoat things. Standard deviation is a process, okay? Nothing that you guys can't handle, however, okay? The standard deviation, like I mentioned, measures how much each data item deviates from the mean, okay? And we have a fancy formula here, okay? But really, we can break this down step by step in order to find the standard deviation pretty easily, okay? The first thing we need to do is we need to find the mean. We know how to do that. We've already learned how to find the mean. Then we need to find the difference between each of the data items in the mean. So we're going to subtract them. Then we take each of those results and square them. We sum them up, and then we divide by n minus 1 data items. So what that means is that if there are 10 data items, we're going to divide by 9. If there were 6 data items, we're going to divide by 5. So you always divide by 1 less. And then our last step is to take the square root. Okay? So if we look at our formula up here, okay, it tells us those steps just mathematically, okay? So we need to take the data item, that x value, and we need to subtract it from the mean, okay? The mean is that x with that bar over it, okay? Then we're going to square each of those, add them up, divide by 1 less than the total number of data values, and then we have to take the square root. Okay. So let's look at what this actually looks like in application. We're going to use those same two students we started out with, and we're going to find the standard deviation for each of them. Okay. Think about this ahead of time. Make a guess. Possibly an educated guess, but which student do you think will have the smaller standard deviation? Okay, go ahead and pick student A or student B, and we'll figure out which one is correct. Now, remember that in the previous slides, we've already determined that the mean for student A was 5. So we're going to use that piece of information. Okay, I've also given us a nice chart here that will help you with the flow of the order in which we calculate standard deviation. Okay, so initially we have already found the mean. That's the first step you want to do. Okay, now we want to list each of the data items. So we've got a 3, a 4, a 5, a 5, a 6, and a 7. Okay, step 2 is going to be to subtract our data item from our mean. Okay, so 3 minus 5 is negative 2. 4 minus 5 is negative 1. 5 minus 5 is 0. Another 5 minus 5 is 0. 6 minus 5 is 1. And 7 minus 5 is 2. Okay. Step 3 now tells us to square each of those deviations that we just found. So we're going to square negative 2, which gives us a positive 4. We're going to square negative 1, which gives us a positive 1. We're going to square 0, which gives us 0. We're going to square 0 again, which gives us 0. We're going to square 1, which gives us 1, and we're going to square 2, which gives us 4. Okay. Now, the next step tells me to add up all of the squares that I just found. So I'm going to add up 4, 1, 0, 0, 1, and 4, and that's going to equal 10. Okay. My next step is now to take that 10 and divide it by 1 less than the data items I have. So if I check out the data items over here on the left, I have 6 of them. So what I'm going to divide by is 5. That gives me 2. And now my very last step is to take the square root of that. So if I take the square root of 2, I get approximately 1.414. Okay. My 4's don't look so good there. Let me try rewriting that. There we go. Okay. So the standard deviation for student A is 1.414. Okay. So having this chart to flow us through that process is really going to be helpful. Let's follow that same process for student B now. Okay. Now remember, I want to find the mean, which I've already found previously. I found that the mean for student B was 5. Okay. Now remember that X with the bar over it just means that's a symbol that we use in math for the mean. So the mean of those data values was 5. Okay. Now I'm going to go ahead and list my data items for student B. I had 0, 3, 5, 5, 7, and 10. Okay. My next step is to subtract my data item and my mean. So I've got 0 minus 5, which equals negative 5. 3 minus 5, which equals negative 2. 5 minus 5 is 0. Another 5 minus 5 is 0. 7 minus 5 is equal to 2. And 10 minus 5 is equal to 5. Okay. Now I need to square each of those results. So I'm going to square negative 5, which gives me 25. Negative 2 squared is equal to 4. 0 squared is equal to 0. Another 0 squared is equal to 0. 2 squared is equal to 4. And 5 squared is equal to 25. Okay. Next step, add all those up. So I'm going to add up 25, 4, 0, 0, 4, and 25. This gives me a sum of 58. Okay. Now I need to take that 58 and divide it by 1 less than the data items I have. So if I look at these data items, I have 1, 2, 3, 4, 5, 6, but I need to divide by 1 less. So I'm going to do 58 divided by 5. Okay. Now 58 divided by 5 doesn't simplify nicely like our previous example did for student B. So we'll just leave it just like it is. And then in step 6, we're going to take the square root of 58 over 5. This is something you can enter into your calculator, and we get approximately 3.406. So, were you right? Student A ends up having the smaller deviation here. Okay? So what that tells us is that student A had less variation of the score. Their standard deviation was lower. Student B had more variations in their scores. Their standard deviation was higher or larger. Okay, in this next example, we're going to tie standard deviation to back what we've done with stem and leaf plots. Okay, so remember that we've got the same data here. We're just gathering it from a stem and leaf plot rather than me giving a list straight up. Okay, so in our stem and leaf plot, we have stems of 0, 1, and 2. With the stem of 0, we have leaves 4 and 8. With the stem of 1, we have leaves 2 and 6. And with the stem of 2, we have a leaf of 0. So that essentially means that we have the data items 4, 8, 12, 16, and 20. Okay? When you have a stem like that that's a 0, you're not going to write 0, 4. That's really just 4. You're not going to write 0, 8. That's really just 8. Okay? So remember, our very first step is to find our mean. So we're going to add those 5 numbers up and divide by 5. So 4 plus 8 plus 12 plus 16 plus 20 is going to give me 60. I'm going to divide that by 5 because I have 5 data items, and that equals 12. Okay. Now again, I'm using a chart here just to assist myself with the flow of standard deviation. So I'm going to list my data items: 4, 8, 12, 16, and 20. Now I'm going to find the difference between the data item and the mean. Okay, so I'm going to do 4 minus 12, which equals negative 8. 8 minus 12, which equals negative 4. 12 minus 12, which is equal to 0. 16 minus 12, which is equal to positive 4. And 20 minus 12, which is equal to 8. Okay, so that was step 2. Step 3 is to square each of those items. So I'm going to square negative 8, and I get 64. If I square negative 4, I get 16. If I square 0, I get 0. Positive 4 squared is equal to 16, and positive 8 squared is equal to 64. Now, my next step is to add them all up. So I'm going to add up 64, 16, 0, 16, and 64. And I get a grand total of 160. Now I need to divide 160 by 1 less than the number of data items I have. So to start out with, I had 5 data items, so I'm going to actually divide it by 4. So I need to do 160 divided by 4. And that's actually going to simplify for me pretty nicely. That's just going to be equal to 40. And my last step is to take the square root of 40, put that into your calculator, and you're going to find that it's approximately 6.325. So my standard deviation is 6.325. Now, let's talk about how we can interpret standard deviation. So it actually has some context to it. Okay, we have exam results for 2 classes. We have Mrs. A's class, or Mr. A's class, and Mr. B's class. The mean for Mr. A's class is 75. The standard deviation is 4. And one of the students in Mr. A's class, Sarah, got a score of 79. In Mr. B's class, the mean was 73. The standard deviation was 3, and Molly's score was 79. So, if Molly and Sarah met themselves outside the hallway afterwards, what'd you get on the test? What'd you get on the test? They both got a 79. Okay, so they're thinking they did just as well as each other. Okay. Sarah's score is 1 standard deviation above the mean for her class, and Molly's is 2 standard deviations above the mean for her class. So, relatively speaking, who actually performed better? Even though they both got a score of 79, Molly actually performed better compared to the rest of her classmates. Okay? Think about this. In Mr. A's class, I keep making that blue box when I don't want to. In Mr. A's class, there was an average of 75. Okay. Sarah's score was a 79. Okay. The standard deviation was 4. So to get from 75 to 79, all I had to do was add 1 standard deviation. Okay. In Molly's class, the mean was 73. She got a 79, but the standard deviation in her class was a 3. So, 1 standard deviation would be 76, and then 2 standard deviations is where she's sitting at with a 79. So relatively speaking, Molly actually performed better than Sarah on her test. A common application of standard deviation comes from manufacturing. Okay? It's used by manufacturers who need to ensure consistent quality in their products. So if you want to have a consistent, good quality product, you want your standard deviation to be small or low. Okay? If you have a large standard deviation, it means that your manufacturing is not consistent or isn't good from one product to the other. Okay? So let's look at a battery company. We have 2 battery companies that tested the battery life for 10 of their randomly selected batteries and recorded the number of minutes each battery lasted. So that first company, we're going to call it Eversteady. They had times of 30, 30, 39, 40, 45, 50, 50, 53, 60, and 63. The second company, Suracell, had times of 30, 33, 33, 36, 37, 39, 40, 45, 47, and 50. Now, lucky us, we don't have to find the standard deviation, they give it to us. So they tell us that Eversteady's standard deviation is 11.4 and Suracell's standard deviation is 6.6. So since consistent performance is important to companies, in general that's true, but specifically we're looking at companies that make batteries, which company is producing the better battery? Okay. Suracell is producing the better battery because their standard deviation is smaller. The smaller the standard deviation there is, the more consistent in quality that the product is. Okay, so let's make a note of that. Suracell because smaller standard deviation. Which means more consistency. Okay. So, when you buy a pack of batteries from the store, you want to know that most of your batteries are going to last a good amount of time. You don't want to put one battery in and have it last 10 minutes and put another battery in and have it last an hour and a half. You want consistency among those products. So, I hope that helps you some with standard deviation and with range as well. Standard deviation is definitely a process that you're going to need to make sure that you practice. So it's going to be super important to make sure you get a good start on this on the homework for this section. Practice is really what's going to help you get into that groove of the process of finding standard deviation. Good luck. Feel free to email me questions if you have them. Otherwise, I'll see you in class on Monday.